This is Ed Robinson, continuing with our lessons on C#. Today we'll be considering the link method syntax. For example, we have .select. So the method syntax is characterized by dots in between methods. We'll also be talking about lambda functions. A lambda function where we have this arrow. Lambdas are characterized by this arrow symbol. We can combine the method syntax with the lambda functions. You'll recall that last time we were talking about linked queries, and we used the implicitly typed var, which means it finds out what type it is at runtime, as you recall, and in this case var turns out to be a collection. Let's take a look at some of what we call extension methods. Now, if we set our var, which could turn out to be a double or an int or whatever, but so it's very convenient to use that. We take a look at all the extension methods we have available to us. For example, we could talk about the max, and we could try that. And that should find the maximum value, which indeed is 6. If we were to, as we single step, we could take a look at that. And if I press F11 again, now as I press F11, I press it once and it goes into the query, but I'm going to press it a total of 7 times. That's 1, 2, 3, 4, 5, 6, 7. It's actually executing the query 7 times to find ultimately the maximum value, which happens to be 6. As I mentioned, there are many extension methods here which I can take a look at using the IntelliSense. If I just type a full stop in here, and you can see all of the extension methods available, and a nice description here, which can be quite important sometimes in order to know how to use them. So let's try a selection of those. Min obviously should find the minimum value, which, looking at that, is the minimum there, which is 0. Count will count the number of elements in our array or collection from the num query. Sum will add them all up. Average will get the average. There are 20, add up to 21, divide by 7 gives us 3. The last element, of course, is 1. The first element is 3. Now the first or default, at the moment, it's the first element, which is 3. But if you were to empty the array by just deleting all of that, it would return the value 0, which is the default value, so save you getting an exception. Here, element at 0, that's the first element, in this case, element 0, since it's a collection, starting at 0. Unfortunately, we can't use this notation. That would be nice, perhaps, since it is a collection. Append, when you add 7 to that, you should end up with an extra element. Take 2 takes the first 2 elements of the collection. To list, that converts it to a list. We'll take a look at that. Distinct will mean that it finds it doesn't repeat elements. So this 5 here occurs twice, so it only appears once in the distinct. Now, this is more or less a utility. We're taking range, we're taking all the numbers, 2, and then we're taking 2, 3, 7 of them from starting at 2, so they go up to 8. The question might arise, how would you make them go up as 0.1, 0.2, or some other increment, and a bit more complicated? Well, we'll come back to that. You'll notice that it's of the enumerable class. We're not running it on the query at all. It's on the enumerable class, and this is a method of that class, as indeed are these extension methods. But in particular, we're not attaching it to our query. Repeat, when we have 10 and we want to repeat it 4 times. So if I place a breakpoint at the end and then run my code and then look at the locals window as well, and we'll see that what's been produced, these are just a series of numbers down here, and then we've got our collection. So take a look at I, for example. I is when we append, so if we take a look at that, you can see that it's the results view here. You can see that it's got the extra element tagged on the end. So you can take a look at all of those, all of the collections, take a look at M, and you can see there that you've got that series. You'll also notice that these types can be quite complex. So for example, we've got here all these various types, and as I say, they're quite complex looking things, so it is indeed convenient that we can use var as where the type is determined at runtime by looking at what's in it. Incidentally, if we did want to print some of these out, for example, print out the A, which is the result, that should give us 0, of course, and also we could try printing out, for example, the first one here, which is also just a single number. But if we were to print out our collection, don't forget we need to use our for each like this, and then what I'll do is put some write some just blank lines in there as well, so I can see what's going on, and then I can run that, and that should just print out a selection of those. So we've got the, and since I haven't put a read line at the bottom, I can start with that debugging, or Control F5, and that should give me my results, which you can see is for the first one, A, has got the value 0, the second one has got the value of 1, and then I've printed out just one of the collections down there, and you can see the numbers there from 3 to 7. Let me investigate a few of these more closely. Let me start off with taking a look at the count. I find that I can insert what's called a lambda statement, a lambda expression in here. So lambdas always start off with a variable of your choosing on the left, and we have our arrow sign here. I'll explain more about the lambda for the moment, just show you how the result of using them. So in this case we're saying that s goes into s greater than 3. Now what that means is at the end of the day it'll pick out all the elements which are bigger than 3 and count them, and if they're bigger than 3 of elements in the array, so I've just got say 3, 4, 5, 6, so I've got 5 elements in my array, and in this case it's easy to see that the elements bigger than 3 are just the 5 and the 6, so that should give us 3 elements. Let's see if that's correct. If I run that, what I'll do, I'll put the breakpoint down here and run it to there, and then I can take a look in my locals window, and I should see that it indeed has given us, and you'll notice the type is int, so we called it var in the first place, but it's implied. At compile time it knows what it's dealing with, so it's integer, and you'll see the value indeed is 2, because we've got 2 numbers bigger than 3. Let's try some other extension methods which contain lambda expressions as well. So let me try some others. For example, we've got here the first element. This time our lambda expression says we're taking everything which maps into all the numbers bigger than 3, and they're indeed, sorry, we're looking for the first number which is bigger than 3, which indeed is 5, is the first number from left to right, bigger than 3. Here we're selecting all the numbers which are bigger than 3 in this case, so that's the 5 and 6 which are bigger than 3. Now in this case here we're transforming them into double their value, so in fact it'll be 6, 0, 1, 10, 6, and the maximum of those is going to be 12. In this case another boolean here, so it's mapping into a boolean which says, it says is there one which is bigger than 3, and indeed there is definitely is bigger than 3. There's a couple of them bigger than 3 actually, but one's enough. In this case the where, which is a very common extension method, along with our lambda here, so what it's doing here, it's basically selecting the numbers which are bigger than 3 themselves. So the numbers bigger than 3 of course are 5 and 6, and you might try to run that and take a look at the output, so to speak, which is in the locals window. And you can see that this G, for example, is a collection, whereas the others, we've got integer results, and we've got a Boolean result as well for F, where it says if any of them is bigger than 3, then the result will be true. Otherwise, of course, being false if there's no numbers bigger than 3 in the collection. Lambda functions are not easy to deal with, actually. For example, in this case here, we've got our S is mapping into, it's mapping into actually a Boolean, which I mentioned previously, but you could say the result of the function is a Boolean. If you look at this one, though, the result is a new set of numbers which have all been multiplied by 2. It'd be interesting to actually single step down to this, so I'm going to run it down to this particular point, and then I'm going to just press F11. Let me just clear this by right-clicking. We can't actually delete it, a bit of a nuisance. We have to clear all, that's no problem. So now if I single step from here, I'm going to watch how many times I press the F11 key. As I press the F11, now you can see it actually goes up to my query a total of 5 times. So this lambda function has been run 5 times, which is quite magical, really. It's a function which continually gets called. We'll look at the other way of doing that, which is the old-fashioned, or the older way of doing it, I should really say, and see the difference between them, how this does save us a lot of time. So lambdas are functions which get run many times. What would be the alternative to using using lambdas? Well, let's just focus on one of them. How would we actually achieve the same result using an ordinary function? Now we do know that that's a Boolean, so I'll just call it bool instead of using var, since we know for sure what it's going to be. So we need to write a method to see if there is a number bigger than 3 there, yes or no. Method to do the same thing. So call our own static function, which will do exactly the same thing. It ought to return a Boolean. I've better call it F1 and not F, since I've got them there at the same time, or perhaps I'll just comment this one out. And then this does exactly the same thing, but it does operate on the original array, I must say. But you can see how it works. It goes through each element in the array, and if there is one bigger than true, it'll set the flag equal to true. So it'll go through every element. If you were to run that, of course, this function, this loop, is going to be called 5 times, because we've got 5 elements in our array. You might like to do that to confirm it. It runs 5 times. Well, I'll just do that very quickly. If I run it down to here, and then we can just continue F11. And you can see it's iterating through those elements in the array 5 times. And then finally it kicks out with a return value of b, which ought to be true, of course. And now it returns. So it's effectively returning the value of s greater than 3 as a Boolean, and returns it back to here. And you'll see the result there should be true eventually. Right. Now, because this is exactly what this function does here. It does exactly the same thing. So I can run that. I'll just stop that. And indeed, you can see that you notice I've placed some parentheses around here just to sort of give you the idea that it's an input variable. And then this is the actual result, which is a Boolean result. So this is indeed a function. So you could say that this thing here means return. People say it means goes to s plus greater than 3. I'd prefer to consider it as meaning it returns s greater than 3. So let's see how that, if we put our breakpoint here and run that, you should see that this lambda function is being called many times. So I'll just single step through this, and as I do, you can see that it's being called many times. So At the end of the day, therefore, in summary, a lambda function is a function which gets called many times, and it's a one-liner, a single line function, an anonymous function. It doesn't have any name like we've got for our function here. So that's what a lambda is. Let's take a look at another query here. We've got a query for the numbers where numbers greater than 3, we want to sort them in ascending order, and you'll see that those numbers should be 5 and 6 because there are only two numbers, 5 and 6, and when you sort them they're already sorted actually, but we sorted them and they produced 5 and 6. Now this is what we call query syntax. So there is another way of writing exactly the same thing, which is called method syntax. Let's see what that looks like. The method syntax to do the same thing looks like this. We'd better call our previous, or we'll better comment this one out. But this does exactly the same thing using the full stop operator really, so that you can see that you'll get IntelliSense help as you press down, and you can see if you press O now, you see it comes up. The extension methods come up. So this ought to do the same thing, but you'll notice that we are using lambda functions as well. This might seem to be a bit redundant, but I'm afraid it is required. So if you were to run that down to your breakpoint, then you ought to see that num query will contain exactly the same set of results. So running it down to the breakpoint, we can see that our num query at the moment is null, but if I'll single step that, F11, and you can see that now that's been populated. Look at the results, and I've got 0 and 1. So that gives an identical result to the line above, the var query here. But here we're using method syntax, and here we're using query syntax. It's usually recommended that query syntax is used to do, but it just outlines a principle that I want to show you, so that the numbers should indeed be 10 and 12. Now, so let me just check that by running it. And now I'll press F11, and we can see that indeed if I can find my window, that's the debug windows and locals window, and we should find that in our num query the results are going to be 10 and 12. That's fine, but what I really want to illustrate is the idea of what we've got in our what we call predicate, that is to say the lambda function, this bit here at the end. In this case, when we're using where, we're using a Boolean output, whereas when we're using a select, we've got a function, if you like, and we're multiplying each element by 2. So the return, this is what is returned. Every element is multiplied by 2. At the same time, it won't work to try and multiply these by 3 or something or other. So do keep in mind that this is usually a Boolean at the where. They're hard to use, I must admit, but keep in mind this ought to be a Boolean here. I'll just take that back. Boolean here, and this is our function return. You might like to take a look at if I go to IntelliSense, I'll press the full stop and look at the where here. If I were to look at that, you can see in here that it says it's got a func, and it's a predicate that's returned, meaning, and it's returning a Boolean in this case here. And if you look at the help for the select as well, using IntelliSense, if I look at select, you can see that it produces a T result here, a selector. So in other words, not a Boolean. So that should give you some. It looks a bit messy, but it does give you a clue if you can find it in there. lastly, let's take a look at link and objects. So we better create some objects first of all, in which we can experiment with. So here we are. We've created new three students with associated scores. So we need to try and see how we can apply link to this. So at the moment we might try and select all the students. We could run it down to there and take a look at the result in our locals window and just make sure we do have all of our students. So if I F11 here and then take a look at the query result, in the results view I can see that I've got 3 objects here. I might like to print them out, for example, using my for each, keeping in mind that they are indeed a collection. Let me just break this up so I can see it more easily. And I could put any additional where clauses in there. For example, we might want to find all the ones which have got a value, a score which is bigger than 10, for example. So I could try that, and that should, let's just take a look at that. So indeed that should just take the 2 values, the two students who've got scores bigger than 10, which are the 1 and 3. We've got here, we can consider this as an exercise really. We've got a practical problem here, that here we've got a dictionary consisting of codes which are actually Lorentz machine, German Second World War coding of, and part of the Lorentz machine, and we can the binary sequence, but the problem is for me that we can't actually put in the sequence in here, the 1 1 using the value. We can't go backwards. So the best we could do is really have a loop, looping through all the values and then trying to find the key. So you might try something like this, and so if we were to run this, it should give us the bind, which is 1, this one here corresponds to D, so indeed it does give us the D. So what we're doing here is taking the value and giving us the key. But the problem could be for you, if you want to, is to try and replace this by one single link statement.